Okay, paper 1, question 9. Matt and Dan cycle around a cycle track. It's saying that Matt, for 1 lap, will take him 50 seconds. And for Dan, it takes him 80 seconds to go around for 1 lap. Quite a common type of question here. They both start at the same time cycling round, and the idea is when will they both end or start a new lap at the same time, or where will they both end up at the start? This is a common, lowest common multiple type question, okay? So that's what you're figuring out here. The lowest common multiple of 50 and 80 is going to give you the total time it will take before they're both back at the beginning. Now, you can do these sort of a trial and improvement way, where you have that Matt's going to finish each lap after 50 seconds, then 100, then 150, then 200. And similarly with Dan, he'll finish after 80, then 160, then 240. In other words, you just keep going up the 50 and 80 times table. That will get you the answer eventually, but there is a quicker way of doing it, okay? It starts with taking each of these numbers and breaking them down into prime factors. So that's precisely what I'm going to do with the 50 and the 80. Now when you're breaking these down into prime factors, remember it doesn't actually matter which 2 factors you begin with. So with 50 I can go with 2 and 25, or I can go with 5 and 10. With 80 I could go with 2 and 40, I could go with 10 and 8. It won't matter as long as you keep breaking down each number more and more until sort of the ends of each of these branches in a way. Every single number at the end is a prime number, you'll get the same answer. It'll just be that the numbers will appear at different places. So I'll go with 5 and 10. 5's a prime number, so I'm going to circle it as such. 10's not, so I break it down. 2 and 5 is the only thing you can do. Should mention, you never break these down with 1 and itself, because if I split 50 into 1 and 50, you've not done anything, okay? So 5, 2 and 5 are the prime factors of that. 80, we'll go with 10 and 8. Gives me 2 and 5 for 10, both of which are prime. For 8, I'm going to get 2 and 4. 2 is prime. Keep breaking up 4, and I'll get 2 more 2's like so. Okay? Next one we do is we present these prime factors of each number in terms of a Venn diagram. So we have 525, and we have 22225. Okay. Those are your prime factors of 80. And those are your prime factors of 50. And what you're trying to do here is that anytime you see one that is common, that they share, you move it into this middle bit, which represents the sharing between the factors of 50 and the factors of 80. So hopefully it seems pretty simple to see that 5 is common in both of them. So I get rid of them from there and instead put it inside like so. You've got 2 that's common in both of them, and I put it like that. Okay? What we then do is we take every single one of these values you see. So the 5 that just belongs to the 50, the 3 2's here that just belong to the 80. Then you take the 2 and the 5 that they share, and you multiply them all together, and that will give you your lowest common multiple. So I'm going to have a grand total of 4 2's and 2 5's that are multiplied together. It's a non-calculated paper, so you're just going to have to go through the motions of actually figuring that out. 4 2's are 16, 5 times 5 is 25, 400. If you need to do long multiplication, do it. I'm not expecting that you would do that in your head like I just did there, but I'm not going to waste time setting out the sum. 400 seconds is the lowest common multiple. Okay? Now just to clarify why we do what we did there, okay? Why is it that I've decided to take these 2 5's in the middle and take these 2 2's and put them in the middle? Well, one way that you can find a common multiple between 2 numbers is simply just to multiply them together. So that's quite a common thing you do when you're finding equivalent fractions, when you get a lowest common denominator before adding them together, taking them away from each other. The likes of if you had over 3 and over 7, you do 7 times 3. Well, if I did 50 times 80, I get 4,000, okay? And sure, 4,000 is a multiple of both of them, okay? But there are lower ones because 50 and 80 happen to go into a number that is a multiple of that, alright? Now when you pool these two 2's and you combine them into one, you're basically getting rid of a times 2 effectively, because you're ignoring one of them. And when you pool these two 5's in, you're basically getting rid of a times 5 and ignoring them, okay? Now when we did that, we got 400 as our answer. And hopefully you'll notice here, if you take 400, multiply by this 2 that we chose to get rid of, multiply by this 5 that we chose to get rid of, that gives us this. Or in other words, if you multiply the two numbers together to get a common multiple, if those two numbers happen to share any factors, you can divide this by them to get a number that is even smaller, that is a common multiple. In this case, they share a 2, they share a 5, so if you divided that by 2, you divide that by 5, you get this. So that is why we do what we do here. Okay, when you share them and pool them together, it's basically this, okay, you find a common multiple, but we can find one smaller. Because they share it by 2, you can half that 4,000. Because they shared it by 5, you can half that 2,000 that you get from the 4,000 before. Okay? Oh, almost forgot. Didn't answer the question. Probably good that I did that. Common mistake, folks, would be you kind of do all the maths bit like that, and then you forget what it was you were doing in the first place. It asks you how many laps each do before they meet again. So you've got 400 seconds is how long it takes before they meet again. Because Matt does that each lap in 50 seconds, Matt's going to have those 400 divided by 50, meaning it's 8 laps before he sees Dan again. And because Dan takes 80 seconds, hopefully you'll be able to clock straight away that he should do less laps than Matt because he's slower than him. He does each lap in 80 seconds, so he will only get through 5 laps. So the actual answer to the question is that Matt takes 8 laps, Dan takes 5 laps before they meet each other again at the finish line.